Today in this video we will be doing exercise 6.2 question number 4 to 7. In this question it's given that the line DE is parallel to AC, DE is parallel to AC, and DF, this is DF, and it's parallel to AE. We have to prove that BF to FE is equal to BE to EC. So let's start with that DE is parallel to AC. So in triangle ABC, it's already given that DE is parallel to AC. So by BPT theorem, we can say that if DE is parallel to AC, so we can say BD by AD will be equal to BE by EC. So we can say that BD by DA will be equal to BE by EC by BPT theorem. Now in triangle, now it's given the second thing is DF is parallel to AE. So we will take triangle ABE. It's already given that DF is parallel to AE. So from here we can say that BD by AD will be equal to BF by AE. BD by AD will be equal to BF by AE, FE. So if these two are equal, and if you look at these two equations, let's say it's 1 and it's 2. From here, if you observe BD by AD is equal to BE by EC, and BD by AD is also equal to BE by EC. From here, we can say that BE by EC will be equal to BF by FE. Hence, it is proved. Now in the next question, it's given that DE is parallel to OQ, DE is parallel to OQ, and DF is parallel to OR. This is DF, it's parallel to OR. We have to show that lines EF and QR are parallel. EF is parallel to QR. So to prove that, let's take the first one, DE is parallel to OQ. In triangle POQ, it's given that DE is parallel to OQ. From here, by BPT, we can say that PE by EQ will be equal to PD by DO. So PE by EQ will be equal to PD by DO by BPT. Now in the next triangle, we will use DF is parallel to OR. In triangle POR, it's given that DF is parallel to OR. From here, again by using the BPT, we can say that PD by DO will be equal to PF by FR. So if we look at, this is equation 1 and this is equation 2. From 1 and 2, if you look at that, PE by EQ is equal to PD by DO. So PD by DO is equal to PE by EQ, and PD by DO is also equal to PF by FR. From here, we can say that PE by EQ will be equal to PF by FR. If we look at the figure, PE by EQ will be equal to PF by FR. So here, now in triangle PQR, we have proved that these two ratios are equal. So now by converse of BPT, we can say that if the ratios are equal, we can say that EF is parallel to QR. Hence it is proved. Now in the question number 6, A, B and C are the points on OP. A is a point on OP. B is a point on OQ. C is a point on OR. Such that AB is parallel to PQ, AB is parallel to PQ, AC is parallel to PR, and we have to show that BC and QR these two are parallel. Now it's given AB and PQ are parallel, so we will first take triangle POQ. It's given that AB is parallel to PQ. If these two are parallel, so from here we can say that OA by AP will be equal to OB by OQ. Now in triangle POR, it's given that AC is parallel to PR. From here, if AC is parallel to PR, so we can say that OA by AP will be equal to OA by AP will be equal to OC by CR. Now if we look at these two equations, here we are saying OA by AP is equal to OB by OQ, and OA by OP is also equal to OC by OCR. From these two equations we can say that OB by OQ will be equal to OC by CR, OB by OQ, OA by AP will be equal to OB by its BQ. OB by BQ is equal to OC by CR. So in triangle PQR we have got that OB by BQ is equal to OC by CR. So from here, by converse of BPD, we can say that the lines BC is parallel to QR. Hence it is proved. Now in the next question, it's given that a line drawn through a midpoint of one side of a triangle parallel to another side bisect the third side. So in this triangle ABC, it's given that P is the midpoint. It's already given here that P is the midpoint of AB, sorry. So it means AP is equal to PB. These two are equal, and a line drawn through a midpoint of one side of a triangle parallel to the other side, and also this PQ is parallel to BC. PQ is parallel to BC, and we have to prove that it bisects the third side. It means this Q is bisecting the AC, and we have to prove here that AQ is equal to QC. So to prove it, we will be using the BPD theorem. So here it's already given in triangle ABC. It's already given that PQ is parallel to BC. It's given. So by using BPD, we can say that AP by PB will be equal to AQ by QC by BPD. So if these two are equal, so it means it's already given that AP is equal to PB. It means their ratio AP to PB will be equal to 1. So here it implies that if AP to PB is 1, so we can say that AQ to QC will also be equal to 1. It implies AQ will be equal to QC. Hence this point Q is bisecting the side ABC, AC. Hence it is proved